So we're going to finish up just the last little bit here of section 3.6. So we were taking a look at truth tables last time, and there's one more thing in this section that we didn't quite get to, and these are valid argument forms. So there are 4 valid argument forms and 2 invalid argument forms. So the 4 valid argument forms have the names modus ponens, modus tollens, disjunctive syllogism, and reasoning by transitivity. Now you'll notice that the first 2 look very similar. Modus ponens is P implies Q, and modus tollens is as well. Modus ponens then says P underneath it, and modus tollens says tilde Q. So what we actually see happening right here is what we call a direct statement. P implies Q, P happens, so Q results. Okay, so this is, I give a rule, the consequence is this, the rule is broken, that somebody does what they're supposed to, and then the consequence happens. It doesn't, they do the beginning part, then the consequence. The second one is actually what we call a contrapositive. Now we saw that before as well in section 3.4. So there's a rule, P implies Q. The result does not happen, right? Tilde Q, which means the initial condition did not happen either, tilde P. Disjunctive syllogism gives an or statement. It tells you that P or Q can happen, and then it says, but P didn't. So since P or Q had to and P didn't, it means Q did. You could also put in here sort of an additional one that says P or Q, and then tilde Q implies P, okay? So there's no order to P or Q. It could have said Q or P, right? Like the order doesn't matter. So basically what we're saying is that one of 2 statements is going to happen, one of them doesn't. That's what the tilde means, so the other one had to. And then reasoning by transitivity might look a little bit familiar. We actually saw that happen today in our second example. So check it out. Example number 2 had that form. Not that one. Where was I? That one. There we go. It says P implies Q and Q implies R, therefore P implies R. It's exactly what reasoning by transitivity is. If this happens, then this happens. And then if that happens, something else happens. So therefore, if the first piece happens, the last piece happens, right? So like in the examples I've been giving you, if my daughter leaves her shoes on the floor, then mama's not happy. If mama's not happy, then mama takes her shoes, right? That would be an option here. So the last statement says, if daughter leaves her shoes on the floor, then mom takes her shoes. Okay, that's reasoning by transitivity. The next 2 are called fallacy, and these actually have error lines in the wrong space. I can't actually draw those in differently, but let me try and fix them at least for now on here. There shouldn't be a line here or here. The line is actually in the wrong spot. I'll have to fix those on my slides later. There should, in fact, though, be a line underneath this. So let's just fix that in there right there. That's what it should look like. So fallacy of the converse says P implies Q. Okay, so if P, then Q. And Q happens, therefore P must have happened. And the answer is not always, right? So if daughter is supposed to, don't leave your shoes in front on the floor, then your shoes get taken. The shoes get taken doesn't necessarily mean that she left them on the floor or left them in the living room or whatever, right? Maybe she left them outside. Maybe they got stolen, something like that. So it doesn't necessarily mean that it goes backwards and the first part of it actually was not something that happened or was something that did happen. And the second one is exactly the same thing. So this is actually the converse, right? You should recognize the word converse. That showed up inside of section 3.4 as well. And then over here, inverse. Right, so P implies Q. We have the opposite of opposite of P, excuse me. So not P happens does not guarantee that not Q doesn't happen, right? So don't leave your shoes in the living room implies your shoes get taken. If you leave your shoes in the living room, then your shoes get taken. The first piece says you didn't leave your shoes in your living room. That does not necessarily mean your shoes did not get taken. Maybe again, right, you left them somewhere else. So when we're taking a look at these statements, what we're trying to do is what we were doing before with number 3. We're going to put them into this form, and the form needs to match one of these. It's going to match one of these 6 options. And based on whichever one it matches, we'll tell you if it is valid or if it is invalid. And then you should be able to tell why. It's valid by disjunctive syllogism, or it's invalid by fallacy of the converse. Notice no valid argument form can tell you it's invalid, and no invalid form can tell you it's valid. Right? So it doesn't work that way. So when we're looking at this, this says if she buys another pair of shoes, her closet overflows. So she buys another pair of shoes is a statement, P. Her closet overflows is a statement, Q. Here's the if. There's an understood then right here. So this is a line that says P implies Q. The second statement says her closet will overflow. Well, that's what we said Q was. And then we have the line underneath it. And it says she buys another pair of shoes. Well, that's what we said P was. And if we go over here and compare that, that actually matches this one right here. P implies Q, Q, P. This is an invalid argument, and it's because of the fallacy of the converse. So this is invalid by fallacy of the converse. And if you think about it logically, it should make sense that it's invalid. If she buys another pair of shoes, her closet overflows. Her closet overflows, but maybe it wasn't because she bought new shoes. Maybe, she decided to buy some more clothes, right? Or maybe she decided to move a chair into the closet, right? I don't know, but something else happened. It could still be that she didn't buy any shoes, but her closet still overflowed. Let's try another one. If Kerry Woods pitches, the Cubs win. The Cubs do not win. Therefore, Kerry Woods does not pitch. So Kerry Woods pitches right here would be P. The Cubs win would be Q. And again, there's an understood then here. It says the Cubs do not win. Well, the Cubs win was Q, so the Cubs do not win would be tilde Q. We do our line. And then this says Kerry Woods does not pitch. Well, Kerry Woods does not pitch. Kerry Woods pitches was P, so Kerry Woods does not pitch would be tilde Q. So we're going back over 2 slides. We're going to take a look and see which one this matches. And this one matches right here with modus tollens. Therefore, it's a valid argument. So our argument is valid by modus tollens.